Okay, so the next thing we're going to want to do is we are going to want to be able to balance redox reactions. Now the big difference between balancing redox reactions and balancing other reactions is that we also have to be sure to balance the number of electrons that are being transferred. If something loses 3 electrons, something has to gain 3 electrons. If something needs 10 electrons, we can't just have something lose 2 electrons. So we have to take additional steps to ensure that the electrons are balanced. Okay, so what we've learned so far is we are still going to apply those principles. We're going to need to assign oxidation states. We're going to need to determine what has been oxidized, what has been reduced. Additionally, we're just going to have to balance the half reactions, as we'll see. And in addition, we oftentimes have to balance oxygens in various aqueous solutions, and so typically these redox reactions are either carried out in acidic conditions or basic conditions, and so there's some different ways to balance these, and so we'll take a look at either of them. So we'll start off with balancing this one in acidic conditions, and of course that means we have H plus cations available. Okay? And of course, if this is acidic conditions, it also means aqueous, so we have water molecules. Okay, so first things first, oxidation states. Iron 2 plus, okay, we did a manganate permanganate ion, so minus 2 for the oxygens, times 4 is minus 8, overall minus 1, so that means the manganese has to be plus 7. Iron plus 3 is going to be plus 3, and then manganese is going to be plus 2. Okay, so this isn't too bad. Okay, we can see that iron went from plus 2 to plus 3. So what happened? We lost 1 electron. Manganese went from a plus 7 to a plus 2. So what happened? We had to gain 5 electrons. So now you can see right away why we need to make sure we balance chemical or balance electrons. If manganese needs to gain 5 electrons, we know it's going to take more than just 1 iron plus 2 cation. Okay, so what do we do? Next we're going to write out the half reactions. Okay, and we just write our reduction reaction, excuse me, our oxidation, doesn't matter which one you write first, but we want to make sure we're labeling these correctly. So iron 2 plus lost 1 electron to go to iron 3 plus 1 electron. Okay, and then our reduction reaction was MnO4 minus plus 5 electrons goes to Mn2 plus. Okay, in general, we're going to now balance these half reactions for electrons. I generally don't worry about oxygen just yet. I'm going to balance that in the for the overall total equation. But I do know that if manganese is going to gain 5 electrons, I need to have 5 iron plus 2. So I'm going to multiply the whole half reaction by any amount of by any coefficient to balance the number of electrons. Okay, so what is that going to do? That's going to give me 5 iron 2 pluses goes to 5 iron 3 pluses plus 5 electrons. Okay, and we can see that 5 electrons are on both sides, so those sort of cancel out, and that's why we don't write them in the overall chemical reaction. Okay, so if I go back up to my total equation, I know I need coefficients here for 5 for iron plus 2 and 5 for iron plus 3. And now what I'm going to do is I'm going to balance oxygens. Okay, in acidic conditions, I'm going to balance oxygens with water. And then I'm going to balance my hydrogens with H pluses. Okay, that I have available in solution. Okay, so I have 4 oxygens on the left side, so I know I need 4 oxygens on the right side, so I can add 4 waters. Okay, now I have 8 hydrogens on the right side, so I'm going to balance that with 8 hydrogens on the left side. Now you can go through that and you can see that this is a balanced chemical reaction, a balanced redox reaction. Okay, so what about in basic conditions? Okay, we're going to do the same thing. We're going to balance the electrons, we're going to balance oxygens with waters, and then what we're going to do is balance it with hydroxides and then cancel those balance it with hydrogens just like we did. Then one more step, because it's basic solutions, we're going to neutralize all those hydrogens with hydroxides to get it in basic conditions. And that's just sort of a trick we can do to make sure that we have hydroxides and not hydrogen ions. Okay, so iodide -1, MnO4, we already did this, so that's going to go Mn plus 7. Iodine by itself is going to be 0. That's its elemental state. MnO2, we've done this one too as well. So that's going to be -2 for the oxygen, so that needs a +4 for the manganese to get equal to 0. Okay, so now iodine has lost an electron, manganese has gained 3 electrons, so we can say that this is lost 1 electron, gained 3 electrons. So what are we going to need to do? We'll write out our half reactions. Iodide minus goes to iodine. Okay, so here's one additional step that we need to take when we're balancing our half reactions. Notice that there are 2 iodine atoms in iodine, and so we're going to need to have 2 iodide anions, and so each of those is going to lose an electron. So we're going to lose 2 electrons total. Okay. Our MnO4 is going to gain 3 electrons. To yield manganese 4 oxide, or MnO2. Okay, so now we can see that we have 3 electrons being gained, only 2 electrons being lost. So we're going to need to multiply both of these half reactions by some value. These common denominator, we're going to multiply this by 3 and this by 2. Okay, so what's that going to do? We're going to go up to our balanced chemical equation. We could rewrite that here or just go up here. So it's going to give us a 3 for iodide, 2 for permanganate, 3 for iodine, and 2 for MnO2. Okay, so again, I'm going to balance oxygens with waters. So I have 4 oxygens on the left, 2 on the right, so I need 2 more, 2 waters. And then, here's where my steps for basic conditions. First, I'm going to balance hydrogens with H pluses, just like I did, and then I'm going to do a pretend neutralization step with hydroxides, because I've got basic conditions, so I should have hydroxides and not hydrogen ions. Okay, we know that a hydrogen plus a hydroxide will yield a water, so that's what's going to be produced when I neutralize these. Okay, so I've got 4 hydrogens on the right side, so I'm going to need to add 4 H plus ions on the left. Okay, then I immediately neutralize those with hydroxides. So what am I going to do? I'm going to add hydroxides to both sides. So this is going to be plus 4 hydroxides plus 4 hydroxides. These are going to neutralize each other to make 4 water molecules. These stay. And now I have 4 water molecules on my reactant side and 2 water molecules on my right. So what this does is that cancels out 2 of these, and that coefficient becomes a 2. And so if I wanted to rewrite this a little bit cleaner, my final balanced chemical reaction is 2 waters plus 3 iodides plus 2 MnO4 minus ions gives me 3 iodides plus 2 MnO2s plus 4 hydroxides. Okay? And so, the value written in green is my final balanced chemical reaction for this redox reaction. Make sure you always have hydroxides left over if you have basic conditions. And again, you can just balance those with H plus ions like we did at the beginning, and then neutralize with hydroxides by adding hydroxides to both sides of the equation, producing waters, and then of course just cancel out any waters that are on both sides of the equation.